Hi. So we are going to discuss about the problem of longest common subsequence. So let's first understand this problem. In this problem, you are given two strings, S1 and S2, and you have to find the longest common subsequence. Before going ahead, let's first understand what is a subsequence. Subsequence is a string which is generated by deleting some characters from the string without changing any order. Like, let's take an example of a string S1, which is A, B, C, D, E. Now, here, if we delete the character C, then A, B, D, E is the subsequence of the string S1. Similarly, if we delete the character B and C both, then ADE is also a subsequence of S1. But AEB can't be a subsequence of string S1 because there the order of two characters B and E are interchanged. So subsequence is just a string, is a part of a string which is formed by deleting some characters and maintaining the order of the other characters. Now, in this problem, we have to find the length of the longest common subsequence, which is possible among two strings S1 and S2. So, like you can see in this example, if S1 as A, B, C, D, E and S2 as A, C, F, E, then here A, C, E is the common subsequence among the strings S1 and S2, which is of length 3, and which is the answer for this example. Now, like how to solve this? Like first approach that might come to your mind is brute force approach. In this approach, we can generate all the possible strings possible for the string S1 and also all the subsequent strings possible for the string S2. And then we can match them, like which is the longest string common to both the strings S1 and S2. Now you can see like this is an exponential approach. Why exponential? Because for each string, be it S1 or S2, there are exponential amount of strings possible, subsequent strings possible. Let's take an string S, which is of length n. Then for that string, 2 raised to power n subsequent strings are possible. So, like, this is not at all a feasible approach. This is an exponential approach. So exponential amount of strings possible for each string, and then you have to match them. So let's talk about an optimal approach, a bit optimal approach. Let's first talk about recursion. For applying recursion on this problem, we will take two pointers I and j. I is pointing to the end of the string S1 and j is pointing to the string end of the string S2. Now, here you will come across two cases. Like first case is that the character pointed by pointers I and j is same, which you can see in this example. Like the character E is same to both I and j. So I and j are pointing to the same character basically. So here we have to take that character as a part of the common subsequence because it is common to both the strings and it is currently pointed by the pointers I and j. So the formula becomes taking that character as a part of the common subsequence. So we are taking 1 and then adding 1 to the length of the common subsequence possible for the remaining strings. Now, here other cases that what if the character pointed by I and j is different? So here also comes two sub cases for this case. We have like you can see if they are not same, they are not pointing to the same character, then we have to skip one of the character. So here two cases. Either we can skip the then here are the two cases. Either we can skip the character pointed by the pointer I, or we can skip the character pointed by the pointer j. So you might be thinking that like third case is also possible when where we can skip the character pointed by both pointers I and j. But see, that case is already encountered among these two cases, 2.1 and 2.2. If you subsequently apply the case 2.1 and then case 2.2, then that case, which is, let's say that case is 2.3, is already covered. Now, so this will lead to maximum length, but then we can calculate the maximum length among these by taking maximum of both the cases, either skipping the character pointed by the pointer I or skipping the character pointed by the pointer G. So the recursive tree becomes like this. We will start by two pointers I and J, pointing them to the end of the string, and then if this character is same, if they are pointing to the same character, then we have to just take that character as a part of the subsequence. Else, there are the two. If they are pointing to different characters, then there are two cases. Either we can skip the character pointed by the pointer I, or we can skip the character pointed by the pointer J. So now you can see the recursion for this problem. Either case one, if the characters pointed by the pointer I and J is same, then we have to return 1 plus the length of the common subsequence possible among the remaining strings. Else, if they are pointing to different characters, then we have two cases, either skipping the character I or either skipping the character pointed by the pointer J, and we have to return the maximum among those two cases. So now you might also think that it is again an exponential approach, because we are taking actually we are taking all the cases possible here also. But here we can optimize this approach using dynamic programming. Why? Because if we take a look at this case function f, here we are passing the pointers, two pointers I and j. So we can take care that we shouldn't call the same function again and again for fixed I and j. For a particular I and j, we can already store the result using dynamic programming. So here the substate of this problem will be based on the pointers I and j, what these pointers are pointing to. So we will store the result in the dp of I and j. You will get more clarity when you see the code. So let's code this problem. Now, here we are at the problem page of the LeetCode of longest common subsequence. Here they are giving us the two strings, which are text1 and text2. Let me reveal this to s1 and s2 to have more clarity. Now, here first we have to calculate the length of the strings possible for these strings. So I'm taking n and m and then taking them as the length s1 and s2. Now, we will calculate the result using the function f. In that function, we will pass the strings s1 and s2 and the pointers pointing to their end, and the pointers pointing to their end, which are n-1 and m-1. Now let's write that function f. In that function, we are passing two strings s1 and s2 with their pointers I and j. Now, first talk about the edge case. if I becomes less than 0 or j becomes less than 0, then you have to return 0 because nothing is possible for the remaining strings. Now, here the case, we will take a case 1. If the characters pointed by the pointer I and j are same, then we have to take those as a part of the common subsequence. So we will write the case 1 return 1 plus, and then the remaining, then we will calculate for the remaining strings, longest common subsequence possible from the remaining strings, which are from I minus 1, j minus 1. Else case 2. In case 2, you have to either skip the characters pointed by the pointer I, or you have to either skip the character pointed by the pointer j. So, and you have to return the maximum among them. So the first case is this one, where you will skip the character pointed by the pointer I, or the other case is where you will skip the character pointed by the pointer j. So this will be our recursion. Now, if I run it, then it will give the correct result for the example test. Now you can already see like this is an exponential approach as we have written only recursion. Now here we have to apply dynamic programming. Now you can see that I and j are the only two pointers which are varying across the function calls, across all the function calls. So we have to memorize the results in our dynamic programming table based on those two pointers I and j. So first I will create the dynamic programming table, initialize with none and with a size n cross m. Now I will pass the dynamic programming with reference in the function calls, in all the function calls. Now, here we will see if the result is already memorized in the dynamic programming table, then we will return that result. We don't have to calculate it again. Else we have to store the results in the dynamic programming table returned by the remaining case. So we will store the results in our dynamic programming table if we haven't stored them already. Now at the end we will return that result. Now if I again run it, you will see it passed the test case, and if I submit it, it will pass all the test case. So in this way we can solve this problem using dynamic programming. Thank you.